So the next topic we are going to discuss is speed, distance and time. This is a very important topic. Multiple questions will be asked for the exam. And obviously the equation that you have to learn is speed is equal to distance by time. You will be solving almost all the questions with this equation, but it will be applied in different manner in different situations. So from this equation, if distance is constant, speed will be inversely proportional to time. If time is constant, speed will be directly proportional to distance. And if speed is constant, distance will be directly proportional to time. So these are some relations that you can obtain from the equation speed is equal to distance by time. We will discuss more applications and different kinds of questions as we move forward. So now let's look at the question. A bike travels for 2 hours at a speed of 215 km per hour and another bike travels for 5 hours at the same speed. Find the ratio of distances covered by the two bikes. Here you can see that both the bikes are going at the same speed, so the speed is constant for both the cases, which means distance will be directly proportional to time. So the question here is to find the ratio of distances covered by two bikes. So let's d1 be the distance covered by the first bike and d2 be the distance covered by the second bike. Let t1 be the time taken by the first bike and t2 the time taken by second bike. Since speed is constant, distance will be directly proportional to time. Therefore, d1 directly proportional to t1, d2 directly proportional to t2. So if you divide both of these equations, you will get d1 by d2 is equal to t1 by t2. t1, which is the time taken by the first bike to travel, is 2 and t2 is the time taken by the second bike to travel, which is 5. So 2 by 5. Therefore, d1 by d2 is equal to 2 by 5. The ratio is 2 by 5. If you have trouble understanding the proportionality, then I will give you another method. So S1 is equal to d1 by t1. This is for the first bike. And S2 is equal to d2 by t2 for the second bike. From the question, it is clear that both of the bike travels with same speed. So S1 is equal to S2 is equal to S. I can equate both of these equations. That means d1 by t1 is equal to d2 by t2. And if I rearrange, I will get d1 by d2 is equal to t1 by t2. So it is the same as what we got before. And you will get the answer as 2:5. Two cars start simultaneously from Agartala and Dispur. So before going further, Agartala is the capital of Tripura and Dispur is the capital of Assam. It might be useful for you. So let's look at the remaining of the question. And travel towards each other on a straight line. So A and D. Two cars start from A and D and are traveling towards each other. The distance between them is 500 km and they meet at a point of 200 km from Agartala. 200 km from A. Find the ratio of their speeds. So X is the meeting point and it is 200 km ahead of A, which means it will be 500 minus 200, 300 km from D. So again, how can you solve this question? The equation we have to use is speed is equal to distance by time. And here, the two cars start from A and D at the same time and they travel for the same amount of time before they meet, which means time is constant here and S1 is directly proportional to D1 and S2 is directly proportional to D2. So following on the lines of last question, S1 by S2 is equal to D1 by D2. Distance traveled by the first car is 200 km and distance traveled by the second car is 300 km. So ratio of the speeds of first car and second car will become 2:3. But I hope you understood how to do this using this equation. These are very basic things, but if you understand this properly, then it will help you while you are solving tougher questions and will save you a lot of time. So let's look at the question. A train travels at 1/3 of its usual speed, hence reached the destination 30 minutes after the scheduled time. On its return journey next day, the train started on the scheduled time, initially traveled at its usual speed for 5 minutes, but then stopped for 4 minutes for an emergency. The percentage by which the train must now increase its usual speed so as to reach the destination at the scheduled time is nearest to. So you have to find the change in speed required and you have to find it in percentage. So let the train is traveling from this point to this point, A to B. A train travels at 1/3 of its usual speed. So let the usual speed be x. And here the train is traveling at 1/3 of its usual speed, which means 1/3 into x, x by 3. X by 3 is the speed of the train when it travels from A to B. And because of this reduced speed, it took more time to reach the destination B. It took about 30 minutes more. So let the scheduled time be t. So for the time taken by the train to travel from A to B will be t plus 30. So you have to take t plus 1 by 2. 1 by 2 represents half an hour. So look, if you are given 45 minutes, all you have to do is divide it by 60. So you will get 3 by 4. 3 by 4 hour. So reading the rest of the question. On its return journey next day, the train started on the scheduled time, initially traveled at its usual speed for 5 minutes. So from B to A it is traveling, and it traveled for 5 minutes at its usual speed, but then stopped for 4 minutes. So plus 4 for an emergency. So for completing the question, let's assume that the distance between A to B is D. So let's take the first scenario in which the train is traveling from A to B. You already know that the speed of train is x and the usual time taken by the train to complete the journey is t. And because of the speed reducing to 1/3 of its usual speed, therefore x by 3, the time increased to t plus 1/2. So if you looked at our previous question, you can see that speed is equal to distance by time. And when distance is constant, I'm talking about the initial journey from A to B, the distance is constant, so speed is inversely proportional to time. S1 by S2 is equal to T2 by T1 because of the inverse relation. So speed of the train, if it was traveling at its usual speed, is x, and speed of train in the given scenario is x by 3. Time taken for the train to complete the journey in the second scenario is t plus half, and in usual circumstances the train would have completed the journey in t hours. So we can cancel x and x. 3 will go to the numerator. 3 is equal to t plus half. Bringing t to the LHS, you will get 3t is equal to t plus 1/2. 3t minus t is 2t is equal to 1/2. T is equal to 1/4. So the usual time taken by the train to complete the journey is 1/4 hours. So 1/4 hour means 1/4 into 60, which will be 15 minutes. Alright. I hope you understood the question until now. I will just walk you through it again. We assume the usual speed as x, and we assume the usual time taken for the journey as t, and we found out that t was 15 minutes. And in the given scenario, when traveling from A to B, the train speed was reduced to x by 3. Therefore, the time taken was increased by 15 plus 30 minutes. So 15 plus 30 is 45 minutes. I hope you understood this much. Now let's look at the remaining portion of the question. On the return journey, the train started from B and traveled at its usual speed, which is x, for 5 minutes. My question to you is, how much distance does the train travel from B? The answer will be, if the total distance is d, then the distance traveled by train from B for 5 minutes will be d by 3. I will show you how I got that. So here the speed is constant, which is x, which means d will be directly proportional to time. Therefore, d1 by d2 will be equal to t1 by t2. Let's take d1 as usual scenario and d2 as the current scenario given in the question. Same for t1 and t2. So in usual cases, the train will travel d distance, and let's write d2 as d2 itself is equal to, in usual scenario, the train will complete its journey in 15 minutes or 1/4 if you write it in hours. And t2 is 5 minutes in the scenario, which means 1/12. So 1/4 into 12/1 is equal to d by t2. You get it as 3. d2 will be equal to d by 3. So when train travels for 5 minutes, it will be traveling for d by 3 distance. Let me just rub some of this so I can write things down. So even if you don't use equation, you can simply think it in this way. If the train travels for 15 minutes, it will complete the whole distance d. If the train travels for 5 minutes, which is 1/3 of 15, it will complete d by 3rd distance, provided that the speed remains constant. So you don't even need to write all these equations. So coming back to the rest of the question. So the train has now traveled d by 3 distance and has taken 5 minutes, and it stops for 4 minutes without traveling any distance. So the total time until now is 9 minutes, and now they wish to complete the whole journey in the usual scheduled time, which is 15 minutes. They have already taken up 9 minutes, so only 6 minutes is remaining. So d by 3 is the distance that has already been traveled, which means d minus d by 3, which is 2d by 3 distance is yet to be covered. So the speed required to complete the remaining journey of 2d by 3 will be speed is equal to 2d by 3, and time left is 6 minutes, which is 1/10. 1/10. So the speed here will become s is equal to 20d by 3. Now if you look at the usual speed, it will be speed is equal to d, the total distance, divided by time, which is 15 minutes. You can write it as 1/4. So 1 divided by 4, 4 goes to numerator, s is equal to 4d. This is the usual speed. The question here is to find out the percentage of change in speed. So percentage change in speed is equal to, the new speed is 20d by 3 minus initial speed 4d divided by initial speed, which is 4d. You have to find out the percentage, so you have to multiply it by 100. So you take the LCM here, so you'll get it as 20d by 3 minus 12d by 3, which is 8d by 3 into 4d into 100. So 4d and 8d becomes 2. 2 by 3 into 100. 2 by 3 into 100 will be 66.66%. Now let's look at the options. We have option B as 67. So that is the nearest value to 66.66. So option B, 67 is our answer.